this video, we're going to take a look at how we can factor trinomials that are written kind of in the standard form here. So we're going to be looking at polynomials with three terms: the square term, a x to the first term, and a constant. And we're going to have a series of steps that we go through that tell us basically what two things are multiplied together to give that polynomial. When we do this, we are creating a multiplication problem that will look something like this, where we have two binomials being multiplied together, and there could be addition or subtraction in the middle there. But basically we need to figure out what numbers are going to work to get back to where we started. There are a whole lot of tricks that you can use to do this, a few different methods. We're going to go through one particular one that kind of does it nice out formulaically. But you will be expected to show work for questions like this, and that work needs to be something that doesn't just happen to be a trick that works out. You need to show a valid algebraic method that'll work for any polynomial that you see. So for those of you that have worked with this before, just keep that in mind on your assessments. You will be expected to show valid, legitimate steps out that you could then take and apply to any particular problem. So if we look at our first polynomial here, 2x squared plus 5x plus 3. The first thing that we're going to go ahead and do is find the product of the coefficient of x squared and our constant here. So if I take those two and I multiply them together, that's going to be equal to 6. So now I'm going to be looking for factors of 6 that need to add up to my middle term, -5. Or not -5, +5. The reason that we need these numbers is because factors of 6 gets me that first part of my factor here, because when I multiply those two together, it needs to multiply together to give me the values that I want on the front and on the back end. Then we're going to do something with those numbers that need to add up to 5 here. So factors of 6 that add up to 5, I'm going to use 2 and 3. So my first step is going to be to rewrite my polynomial and swap out 5x using those factors. So the 2x squared is going to stay the same. The plus 3 is going to stay the same because we're writing an equivalent expression. And the only thing that's going to change is that instead of plus 5x, I'm going to write plus 2x plus 3x. We're just making a substitution of equivalent expressions. 5x is the same thing as 2x plus 3x, so I can swap those out whenever I want. Now what I'm going to do is divide my polynomial into two groups. So I've got my first two terms, 2x squared plus 2x, and I've got my second two terms, plus 3x plus 3. And in each group I'm going to find the GCF. So the GCF in my first group, if I look at the coefficients, I have 2 and 2, so 2 is our GCF. And then we've got x squared and x. So the lowest x that's common to both of those is just x, so we pull that out. And now in order to get back to 2x squared, for the first term we multiply by x, and to get to 2x, we multiply by 1. Then we keep going. So here we had a plus sign, so we're going to put a plus sign here. The GCF between 3x and 3 is just 3. And then to get back to 3x, we have to use x. To get back to 3, we have to use 1. I'll know that I have done this correctly when I now have these factors that match. So now, between my two terms that we have here, that x plus 1 in green is a common factor. So I can pull that out. So I have x plus 1. And now we want to say, okay, what do we have to multiply by to get back to the original? Well, to get to 2x times x plus 1, I have to do x plus 1 times 2x. And then to get to plus 3 times x plus 1, I have to do x plus 1 times 3. So this is my fully factored form. We're going to go through those same steps each time. We split the middle term up. We take the GCF of two pairs, and then we essentially take the GCF again. So let's look at another example. I've got 8 out in front and 3. So 8 times 3 is 24, so I need factors of 24 with a sum of that middle term, negative 10. So now we have to think about numbers. So for 24, and it has to add up to a negative number, this means I'm looking for two negative values, because we know that when we multiply two negatives, we get a positive. So I could do negative 24 and negative 1. That's not going to work. I could do negative 12 and negative 2. That's also not going to work. I could do negative 8 and negative 3. That's no good. I could do negative 6 and negative 4. And that is going to give me the values that I need. So once again, we're going to go ahead and rewrite our polynomial. So we have 8x squared. We still have the plus 3. We're going to split up that middle term using those numbers. So we're going to have minus 6x minus 4x. So again, we're taking out minus 10x, which is equivalent to negative 6x minus 4x. If I were to simplify that, I'd get that same thing. Now we're going to take a look at those two groups. So I have 8x squared minus 6x. That's my first group. And then I have minus 4x plus 3. That's my second group. So I look for the GCF between 8 and 6. That's 2. Between x squared and x, that's just x. Then to get from 2x to 8x squared, we have to multiply by 4x. To get from 2x to negative 6x, we have to multiply by negative 3. For the next one, we have a negative sign, so we're going to bring that down this time. And between 4x and 3, there is no common factor, so I'm just going to pull out a 1. That's it. And then to get from negative 1 to negative 4x, we have to multiply by 4x. And to get from negative 1 to positive 3, we have to multiply by negative 3. So this is a little tricky because you've got some sign switching going on, so that's just something you want to look out for. And again, we'll know that we've done it correctly because both of these match up. We have 4x minus 3 here. So that's the common factor that we can pull out. And then once we do that, to get back to the original term, we need that 2x. And to get back to the second one, we need the minus 1. So our factored form is 4x minus 3 times 2x minus 1. If you ever want to check to see if your answer is correct, just use the distributive property and multiply. So if I wanted to check this one, 4x times 2x is 8x squared. 4x times negative 1 is minus 4x. Negative 3 times 2x is minus 6x. And negative 3 times negative 1 is plus 3. If you look, this looks exactly like what we had here, which is why all of these numbers work together. And then we simplify, and we get 8x squared minus 10x plus 3, which is the original problem that we were given. Now, factored form is not simplified. So just be careful, make sure you read your directions carefully and know what you're being asked to do. Every year on the test, we give this problem, 8x squared minus 10x plus 3, and we say factor it. And there's at least one person who factors it and then multiplies everything out and gives this as the answer, even though that was the original problem that we gave you. So just be really careful. If it asks for factored form, this is what you're looking for. All right. Go ahead and pause the video and try 4x squared minus x minus 5 on your own. All right, so for this one, we multiply those outside numbers. So 4 times negative 5, that's negative 20. And when the middle number is a negative 1, so the factors of negative 20 that add up to negative 1 are negative 5 and 4. So we use those to rewrite our middle term here. 4x minus 5x is the same thing as minus 1x. Then we take the GCF of the first two, the GCF of the second two. Now, you'll notice that I wrote plus 4x minus 5x. You could also do this one as 4x squared minus 5x plus 4x minus 5. And you'll get the same answer. The GCF will just be different as you pull it out. So between the first two terms here, that'd be x times 4x minus 5. And then between 4x and negative 5, it's just 1 because there's nothing else. And we have 4x minus 5. So you end up with the same place, with the same answer. The terms just switch places. So on the left side, we have 4x times x plus 1 and negative 5 times x plus 1. So we pull out the common x plus 1, and we multiply that by 4x minus 5. Here we can pull out the common 4x minus 5, and it's multiplied by the leftover x plus 1. Remember, multiplication is commutative, so the order in which you write those two factors does not matter. You will get the same answer if you multiply first times the second as if you do the second times the first. All right, now if we take a look at the next one, we have a coefficient here of 1, there's nothing written, and negative 45, and our middle value is positive 4. So we want factors of negative 45 that have a sum of 4. So since my factors have to be of a negative number, I know I need one positive, one negative. And since my sum is positive, that means that the number that is further from 0 is going to be the positive value. So the positives are going to outweigh the negatives here. So if I'm looking at 45, just general factor pairs are 45 and 1. But no matter where I put the signs, none of that's going to add up to 4. Next up, we have 15 and 3. Negative 3 and 15 doesn't work. 15 and negative 3 doesn't work, so we move on. That gives us 9 and 5. And if we use negative 9 and positive 5, that's negative 4. So we want to flip it and use positive 9 and negative 5. And that will give us what we want. So we go ahead and we rewrite this. Divide that out here. So we have x squared plus 9x minus 5x minus 45. We go ahead and look at our groups. We have the first group, and we have the second group. And then we pull out the GCF. So between x squared and 9x, that's just an x, which leaves us with x plus 9. Between negative 5x minus 45, that's going to be negative 5. And that gives us also x plus 9 again, because negative 5 times positive 9 is negative 45. And if we pull out that common x plus 9, we are left with x minus 5. Now, if we look at this carefully, we might notice that inside those factors, it's just a regular x, and we have positive 9 and negative 5. When the coefficient of x squared is 1, and I'm going to run out of room, then we can take these numbers and go right into the factored form, but only when the coefficient of x squared is 1. Because we know that in order to get to x squared or 1x squared, we have to do x times x. We're not dealing with any other numbers. So that's a shortcut that you can use. You don't have to use it, but it's a shortcut that you can use when the coefficient of x squared is 1. So go ahead and pause the video and try the next one. All right, for this one's a little tricky. So it's 1 with the x squared, so we know that we can jump right to our factors. So we start thinking about those numbers. We want factors of negative 32 that add up to negative 8. Okay, great. 32's got lots of factors. We can play with that. We can try negative 32 and 1. Doesn't work. 32 and negative 1 also doesn't work. Then we go to 16 and 2. So negative 16 and 2, nope. 16 and negative 2, also nope. Moving on. Negative 8 and 4, no. 8 and negative 4, no. And that's it. We've used all the factors. When we have a polynomial that cannot be factored, it's similar to numbers that can't be broken down into other factors, like 17, 23, 5. If there's no way to write that except for that thing times itself, we call those prime numbers. And just like we have prime numbers, we have prime polynomials. So this one is a prime polynomial. We can't break that down any further. All right. The next example is a special one because instead of just x's, we also have y's in there, but our process remains the same. So here I'm looking for my coefficient of x squared, which is just 1, and then my last term, which is 18y squared. And then I'm also looking at my middle term, which is plus 9y. So we're basically doing it the same and thinking about everything that's going on around those x's. So now we want factors of 18y squared with a sum of 9y. So ignore the y's for a minute. Factors of 18 that add up to 9. So it could be 1 and 18, that's too much. It could be 2 and 9, that's not going to work. It could be 3 and 6, that's what we're going to use. So we're going to use 3 and 6. But then we also need this y squared bit, so factors of y squared with a sum of y, that means that each of these needs to have a y attached. So 3y plus 6y is 9y. 3y times 6y is 18y squared. Since the coefficient of x squared was 1, we know that this is going to be just two factors with x in the front, and then we drop those numbers in. So x plus 3y and x plus 6y. Another way you can do this is just to ignore the y's entirely and think about it as x squared plus 9x plus 18, and then drop the y's in once you've got your factored form. All right, for the last one here, we have 8m squared plus 8m minus 6. And when I look at this, the first thing that I notice is that these are all even numbers. And because they're all even, that means that there's a greatest common factor here. So you have two choices. You can take that greatest common factor out in the beginning and then factor from there, or you can wait and do it at the end. So we're going to look at each of those and talk about pros and cons with each one. So the first option, we'll say take the GCF out first. So my GCF here is going to be 2. So this is the same thing as 2 times 4m squared plus 4m minus 3. And now we're going to focus on the inside piece for factoring while keeping everything multiplied by 2 as we work. So we want factors of 4 times negative 3, so that's factors of negative 12 that add up to 4. So if we think about factors of negative 12, we have 1 and 12, make one of those negative, that's not going to work. Then we have 2 and 6. So 2 and negative 6 is negative 4. So we want negative 2 and 6, that will give me the 4 that I want. So negative 2 and 6. So we have 4m squared minus 2m plus 6m minus 3. Go ahead and finish factoring that polynomial, keeping in mind that everything at the end will be multiplied by 2. All right, so we group those terms together. GCF of 4m squared minus 2m is 2m. Pull that out, we're left with 2m minus 1. GCF of 6m minus 3 is 3. We pull that out, we again get 2m minus 1. So altogether, that middle part becomes 2m minus 1 times 2m plus 3, and we multiply the whole thing by 2. So this is what it looks like if we factor the GCF out at the beginning. Go ahead and pause the video and try factoring directly from 8m squared plus 8m minus 6. All right, so if we keep it as it started out, we would need factors of 8 times negative 6, which is negative 48, with a sum of 8. So we figure those out, they're 12 and negative 4. We split up the middle term, we group, we factor, and we end up with 4m minus 2 times 2m plus 3. Now, when we're asked to factor, we want to make sure it's completely factored, meaning that there's nothing else that we can pull out to write in our multiplication. This is why doing GCF at the end can be a little tricky, because you need to be on the lookout for it in your two factors. So if I look at 2m plus 3, there's nothing in common there that I could factor out. Those are relatively prime, so they're good to go. But if I look at 4m minus 2, that is the same thing as 2 times 2m minus 1. So I need to look for that and pull that out, and then put that back together with the 2m plus 3. And you'll see that we get the same answer. We just have to be a little more aware of what we're looking for.